What's up, folks? Find the tangent line to the conic section at x equals 3, given we have this parabola here, 1/2 y plus 6 equals x minus 2 quantity squared. Well, a tangent line is a linear function, which means to write its equation we need two things. We need a point, the coordinates of a point. Let's call them x1, comma, y1. And we also need a slope. Let's call it m. And how are we going to find the slope? Well, the slope is going to be the derivative at that x value, which is 3. So let's go ahead and think about how we can solve this problem. Well, first, let's find the point. Well, what do we know? We know the x value is 3, and so if I take my equation and plug in the x value of 3, I can solve for solve for y. So let's plug in that x value to our equation. What do we have? We have 1/2 times y plus 6. Golly, that's not working very well. Y plus 6 equals x, which is 3 minus 2 quantity squared. Let's see what we can simplify. Well, 3 minus 2 is 1, and 1 squared is 1, so all that jazz right there is just 1. And I have this 1/2 right here, so I want to multiply by 2 on both sides. So let's rewrite this as y plus 6 equals that 1 times 2. So y plus 6 equals 2. And so we can see that then y equals 2 minus 6, which is negative 4, which tells me my point has the coordinates of 3, comma, negative 4. There we go. And so now I have the point, and I need to find the slope. And I'm going to show you that in two different ways. Way number one, what do we have? Well, we have let's write our equation, 1/2 times y plus 6 equals x minus 2 quantity squared. First thing I'm going to do is, I don't like that fraction, so I'm going to rewrite this as y plus 6 equals that 2 times x minus 2 quantity squared. Now I can go through and I can differentiate this function. So what's the derivative of y plus 6? Well, it is just the derivative of y with respect to x. So that should be a y right there. Derivative of that constant term 6 is just 0. It doesn't matter what side it's on. Dy dx is the derivative of y. That's what dy dx means. It means the derivative of y. So when we take the derivative of y, we get dy dx equals, let's take the derivative of the right-hand side. Well, remember our constant multiple rule. I can pull that 2 out, so I can say 2 times the derivative of this expression, x minus 2 quantity squared. And then I can just multiply the 2 in at the end. So let's keep going. Dy dx equals 2 times the derivative of that inside piece right there. And what is the derivative of that? Well, I can use the chain rule, and I can say I'm going to multiply that 2 down front. So I get a 2 there. And then I'm going to leave the inside the same, x minus 2, and I'm going to subtract 1 from the power. So in this case, I just leave a 1 right there. And I'm going to multiply by the derivative of the inside. Well, luckily, the derivative of the inside is just 1, because the derivative of x minus 2 is 1. So there we have our derivative, which I can simplify. Let's write that as 4 times x minus 2. That is my derivative, y prime, dy dx, however you want to write it. Notice that since I used the chain rule, this stayed factored for me, which is kind of nice. So one thing that would be cool if you recognized is that the x value of the vertex is at 2. We found that up here when we factored it, and we also know, sorry, I'm getting crazy, we didn't factor it. But I want you to notice is that x minus 2 is still right here, x minus 2, which means the derivative has a 0 at the x value of positive 2, which should make sense because a parabola has a relative maximum or minimum, aka if you're talking about a vertical motion problem, it has the maximum height when the derivative is 0, when the object at its maximum height, the derivative is 0. So that stayed the same, which is kind of cool. All I ended up with was that 4 right there. So let's see where we go with this. Well, we need to figure out the derivative at the x value of interest. The x value is 3, we were told that. So we need to plug 3 into our derivative. And so let's say that our slope, m, is equal to 4 times our derivative, our x value plugged into the derivative, 3 minus 2. And we can simplify this. So m has to equal 3 minus 2 is 1, so 4 times 1 is 4. And so our slope is 4. So we can write our equation, y minus the y value, which was negative 4. So y minus negative 4 is y plus 4, equals our slope, which is 4, times the quantity x minus our x value. Well, our x value was 3, so x minus 3. And there we have the equation, the tangent line to this function. Now, if you didn't want to use the chain rule, all you would need to do is take this equation right there and fully expand everything out. So x minus 2 would become x squared minus 4x plus 4, and then you'd have that 1/2, so I would multiply by 2, doubling all that, and then move the 6 over, and then solve it for y, and then take the derivative piece by piece. Or you could just use the chain rule, and it's a lot easier.